angular velocity, usually denoted by letter omega. It is the rate of change of angular displacement with time. It is expressed in radians per second, so that is the unit for angular velocity. Angular velocity mathematically can be expressed as angular displacement over time. The symbols are omega equals to delta theta all over delta t, meaning that angular velocity equals to angular displacement divided by the time, or the change in angular displacement over change in time. Since we know that the change in angular displacement is equal to s over r, we can write omega as s over r t. For a complete cycle, angular velocity equals to 2 pi all over capital T. Capital T is the period time or periodic time. Since the periodic time equals to 1 over the frequency, or 1 over f, omega can be expressed as 2 pi f. So in general, combining all the formulas, we have omega equals to delta theta over delta t, or s over rt, or 2 pi over capital T, or 2 pi f. All those formulas can be used in calculations. For example, let's look at some questions. Number 1, determine the angular velocity of a turntable rotating at a frequency of 10 Hz. Solution. Since we know that omega equals to 2 pi f, we need to substitute f in the formula so that we have 2 pi times 10. Simplifying this, we get 62.83 radians per second. Example 2. A car of mass 100 kilograms moves round a circular track of radius 100 meters with a linear velocity of 20 meters per second. Calculate its angular velocity. Solution. We know that v equals to r omega, which implies that omega equals to v over r. So we need to substitute v and r in our formula, and so omega equals to our velocity, which is 20 meters per second, divided by the radius, which is 100 meters. This simplifies to 0.2 radians per second.